Alright guys, welcome to your 25th video, and in this video we're going to be taking a closer look at the gun and bullet problem. So I already told you guys theoretically what should happen. Since both of the objects start out with a velocity of 0, the total momentum of the entire system is 0. Therefore, after you fire a bullet from the gun, the ending momentum, or the momentum whenever the bullet's being fired, is also 0. Does that make sense? Well, hopefully after I show you guys this example, it will. So let me go ahead and draw my trusty gun, and I'll give it a trigger, and I might as well give it a handle too. Now inside the gun you have a bullet. Now make sure my bullet doesn't look like a wiener this time, but we already know from the formula momentum equals mass times velocity that the total momentum of the system has to be 0. Why is that? Well, the gun and the bullet right now, before you fire it, aren't moving at all. So since velocity is 0, momentum equals 0. Now, let's go ahead and throw theory out the window and throw in some actual figures. So what I'm going to do is I'm going to give you guys the mass and the velocity after... Okay, I definitely spelled... Okay, maybe I should give a tutorial on how to spell after. After the firing. So we need two pieces of information. The first one is the gun, and the second one is the bullet. So what information do we have already? Well, I'll say that this gun has a velocity of 30, or excuse me, has a mass of 30 kilograms. And I'll say that this bullet, since it's much smaller, it has a mass of only half a kilogram. Now, after we fired the bullet, some guy was waiting down with a speed gun, and he told us that the bullet shot out of there really quickly at a rate of 400 meters per second. And we said, okay, how fast was the kickback speed of the gun? And he's like, I don't know. We go, you don't know? Didn't you calculate that too? And he's like, no, sorry man, I don't know. That's what you have to figure out. So we'll put a question mark right there, and that's what we're going to figure out, and that's what I'm going to be teaching you guys in this tutorial. How to solve for one of these variables when the rest of the information you have available. Well, let's go ahead and do that right now and figure out the kickback speed of the gun. So again, what we know is the total momentum of this has to be 0 since the initial momentum is 0. So what we do is, in order to get the momentum of each, let's go ahead and figure out the momentum of the gun first. Mass of the gun times the velocity of the gun will give us the momentum of the gun. Now what we need to do is add this together with the mass of the bullet times the velocity of the bullet, and whenever we add these two things together, we have to end up with the ending momentum of 0. So the very first thing we want to do is we want to figure out the momentum of the gun, mass times velocity. Well, you take the mass of the gun, which is 30, and I'll throw out my units for right now, and you times it by the velocity of the gun. Now, of course, that's what we're trying to figure out, so we don't have that information yet, so just go ahead and put X as a placeholder. Now what we need to do is we need to add this with the mass and velocity of the bullet. So the mass of the bullet was 0.5, and the velocity of the bullet was 400. So let me just go ahead and throw those in parentheses, and I'll say that this entire thing equals 0. Well, let's go ahead and figure out this part right here. First of all, whenever you take 0.5 times 400, you get 200. Now, what we have right now is 300x equals 200, or excuse me, getting ahead of myself here, plus 200 equals 0. Now you guys can probably figure it out from here, but in case you don't know what to do, in order to figure out x, what you need to do is subtract 200 from each side, so you get 30x, and it's equal to negative 200. And now, of course, the velocity of the gun is x, so what we need to do is get x alone. So take negative 200 and throw it over 30, and also you throw this over 32, and you end up with x equal to, and it's actually equal to negative 6.6 repeating, and the units that we were working with is meters per second. So tell whoever was asking us for this information the police officer or the guy calculating, or maybe we just were curious, that whenever you fire a gun with a mass of 30 kilograms and the bullet is half a kilogram and it's firing at a rate of 400 meters per second, then the kickback speed of the gun is negative 6.6 meters per second. And if you guys are saying, okay, 6.6 meters per second, why the heck is this negative right here? Well, the negative symbolizes direction. It basically means it's moving in an opposite direction than the bullet. So since this is positive right here, 400 meters per second, it means that the bullet is going to go this way, and a negative number means the velocity would be this way, opposite directions. So that is how you calculate one of the variables when you have the rest of the information, thus proving the law of conservation of momentum. So that's all I got for you guys for this tutorial. I don't know what we're going to be covering in the next tutorial, but it's going to be epic. So thank you guys for watching, and I'll see you guys then.